Welcome to this session on common welding discontinuities as per AWS B1.10. Today, we'll explore typical flaws found in welds, their causes, and how to inspect them. Understanding these discontinuities is essential for ensuring structural integrity and compliance with standards. In this section, we'll cover the purpose of identifying discontinuities, key definitions, and reference tables. We'll also look at weld zones, which are critical for mapping and evaluating discontinuities. Welding discontinuities are interruptions in the typical structure of a weld that may or may not compromise its integrity. The purpose of this presentation is to help inspection engineers identify and classify common welding discontinuities according to AWS B1.10 standards. It is essential to distinguish between a discontinuity and a defect. A discontinuity is any irregularity in the weld, while a defect is a discontinuity that exceeds acceptance criteria and requires corrective action. Understanding these concepts ensures accurate evaluation and compliance with codes such as AWS B1.10 and API 1104. This section introduces the terminology and sets the foundation for detailed exploration of each discontinuity type, including their causes, inspection methods, and implications for structural performance. The AWS B1.10 reference table lists common discontinuities, their typical locations, and remarks for inspection. Weld zones include weld metal or WM, base metal, BM, heat affected zone or HAZ, and weld interface IRWI. Mapping discontinuities to these zones helps inspectors infer mechanisms and risks. For example, porosity usually occurs in WM, lamellar tears in BM near HAZ, and undercut at WI/BM. Understanding these zones is critical for accurate diagnosis and reporting. Inspectors should familiarize themselves with these definitions before proceeding to specific discontinuity types. Next, we'll discuss gas-related and fusion discontinuities, including porosity, incomplete fusion, and incomplete penetration. These are among the most common issues encountered during welding. Porosity refers to gas pores trapped in the solidifying weld metal. It can appear as uniform scatter, clusters, piping, aligned, or elongated forms. Causes include contamination, moisture, improper shielding, and incorrect arc length. Inspection methods include visual testing, VT, with good lighting for surface pores and radiographic or ultrasonic testing for internal porosity. Acceptance depends on size and distribution per code limits. Porosity can reduce weld strength and lead to failure under stress if excessive. Incomplete fusion occurs when weld metal fails to coalesce with base metal or between passes, often due to low heat input, improper technique, or surface contamination. Incomplete joint penetration refers to failure to penetrate the root of the joint, typically caused by inadequate root opening or low current. Both discontinuities are critical because they create stress concentration points. Inspection involves VT, magnetic particle or penetrant testing for surface indications, and ultrasonic testing for internal planar defects. These conditions are usually rejectable in structural applications. Profile and surface discontinuities include undercut, underfill, overlap, and profile deviations. These affect fatigue resistance and structural performance. Undercut is a groove melted beside the weld toe that is not filled with weld metal, caused by high current or excessive travel speed. Underfill occurs when the weld surface is below the adjacent base metal profile, often due to inadequate filler deposition. Overlap happens when weld metal rolls over the base metal without fusion at the toe, typically from low travel speed or incorrect electrode angle. These discontinuities affect fatigue resistance and structural integrity. Inspection uses visual gauges to measure depth and profile, and acceptance depends on code limits. Profile discontinuities include concavity, convexity, and excessive reinforcement. Concavity indicates insufficient fill, convexity shows excessive deposition, and reinforcement refers to excess weld metal at the face. These conditions can alter stress flow and lead to premature failure. Inspectors use profile gauges to measure compliance with design specifications. Smooth transitions and adherence to maximum limits are essential for structural performance. Now we'll look at discontinuities in the base metal, such as lamination, delamination, seams, laps, lamellar tears, and cracks. These can severely compromise weld integrity. Lamination and delamination are planar separations within the base metal, often resulting from rolling defects or service stresses. Seams and laps are surface defects aligned with the rolling direction, which can compromise weld integrity if they intersect the heat-affected zone. Causes include steelmaking irregularities and poor rolling practices. Ultrasonic testing is the primary method for detecting these discontinuities, while visual inspection can identify surface breaking defects. Their presence near critical zones often necessitates rejection or repair. Lamellar tears occur in the base metal near the HAZ due to through-thickness strain on nonmetallic inclusions, commonly under high restraint conditions. Cracks, whether hot or cold, longitudinal or transverse, are among the most severe discontinuities. Hot cracks form during solidification, while cold cracks develop after cooling, often due to hydrogen or high restraint. Inspection methods include magnetic particle or penetrant testing for surface cracks and ultrasonic testing for internal defects. Cracks are generally rejectable regardless of size. Finally, we'll discuss critical weld locations like toe, root, and underbead, and outline the inspection workflow for accurate reporting. The toe is the intersection between weld metal and base metal, a common site for undercut and lack of fusion. The root is the opposite face of the first weld run, critical in full penetration joints. Underbead cracking occurs beneath the weld bead in the HAZ due to hydrogen and restraint. Prevention includes preheating, using low hydrogen consumables, and controlling cooling rates. Inspection involves visual and ultrasonic testing, with delayed cracking checks after hold time. Inspection begins with reviewing the welding procedure specification, WPS, and acceptance criteria. The inspector maps indications to zones, selects appropriate methods, VT, MT, PT, UT, RT, measures size and spacing, and classifies discontinuities according to code. Reports must include location, type, size, NDT method, criteria, and disposition, along with photo evidence and measurements. Accurate documentation ensures traceability and compliance with standards.